What kills all civilizations in space? A quick note before anything else. Everything you are about to hear is based on real science, real books, real researchers. The names are real. The numbers are real. The silence is very, very real. This is not a conspiracy video. This is not about government cover-ups or classified UFO programs. This is about math and physics and evolutionary biology and what they collectively say about the future of our species. Some of it is hopeful. Most of it is not. Fair warning before we begin. This video ends in a dark place. Not because we are trying to be dramatic or chase cheap clicks, but because when you follow the science honestly, when you actually sit with the numbers and the silence, you end up somewhere uncomfortable. If you are easily unsettled, maybe close this one out. Or stay, but do not say we did not warn you. So, let us talk about the silence. Blaise Pascal, the French mathematician and philosopher, once wrote that the eternal silence of infinite space terrifies him. He wrote that in the 17th century, centuries before we had radio telescopes, before we had mapped the full breadth of our galaxy, before we understood just how unimaginably vast and ancient the universe actually is. And yet somehow, that single sentence might be the most scientifically accurate thing a human being has ever written. Because the universe is ancient, it is enormous, and it is absolutely, devastatingly silent. Here is a simulation of galactic colonization. In this model, ships from a civilization travel at speeds comparable to what we can actually manage today, roughly 30 kilometers per second. After arriving at a new destination, the freshly established colony is given a full 100,000 years before it sends its next ship to the next unoccupied star. The maximum travel distance for each voyage is 10 light years. Each journey takes 300,000 years. And with those ultra-conservative, almost laughably pessimistic assumptions, what happens? Almost the entire Milky Way gets colonized in under 1 billion years. 1 billion years sounds like an eternity. But think about this. There was a moment in the history of this planet when dinosaurs had already been walking the Earth for more than 100 million years. If a civilization capable of interstellar travel existed on the other side of our galaxy at that point, and if they could travel at even 1/1000th the speed of light, which is already well within the realm of theoretical possibility, they would be here. Not in the sense that they chose to come specifically to us. No, they would have had time to spread across the entire Milky Way. Many researchers who study this question specifically give timelines no longer than 50 million years for a determined species to colonize the whole galaxy. That means a civilization that arose even a tiny fraction of a percent earlier than ours in the lifespan of the universe could have colonies on every suitable planet in our galaxy. Look up at the sky. Do you see anything? Nothing. You see nothing. And we are going to spend the next hour figuring out what that means. That question is the heart of what we are going to talk about today. But before we get into it, this is not just an astronomical curiosity. This question might be the most important question our species has ever faced, because the answer tells us something about our future, something we might not want to hear. Let us start by asking something that almost nobody asks first. Do we even know what we are looking for? Billions of words have been written about extraterrestrial life. Hundreds of films, thousands of documentaries. Since roughly the beginning of the 20th century, an entire culture has grown up around the idea of intelligent beings from other worlds. And there is always something about those stories that feels off. Something that nags at you, even if you cannot name it. In 1896, the writer Herbert Wells published an essay called The Intelligence of the Martians. At the time, many scientists genuinely believed Mars harbored life. Wells argued that if you accept the idea of life evolving from biological matter on Mars, you should easily be able to suppose that Martians would differ from humans not just physically, but functionally, and that the differences could stretch beyond the limits of human imagination. Think about that phrase. Beyond the limits of imagination. Because here is the uncomfortable truth. Our imagination is not nearly as unlimited as we believe it is. Look at any depiction of aliens in popular culture. Really look. No matter how abstract or frightening they appear, they always echo something we have already encountered. Tentacles from ocean creatures, compound eyes from insects, bipedal forms from our own bodies, a head, some limbs, some kind of face. What we call creativity is, in practice, almost always just recombination. We shuffle the deck of things we have already seen. We cannot truly imagine something we have never experienced. The British philosopher John Locke put it bluntly, "There is nothing in the mind that was not first in the senses." A publication called The Barlow Guide to Extraterrestrials came out in 1979. Illustrated by the artist Wayne Barlow, it was a kind of scientific fiction encyclopedia depicting alien species from dozens of science fiction works, from various novels and short story collections of the era. It was nominated for the American Book Award and the Hugo Award in 1980. And what it demonstrates, beautifully and unintentionally, is exactly this limitation. Every single creature in it, no matter how strange it looks, is recognizable as a creature. It has something like a face. It moves in ways we understand. It occupies space the way living things on Earth do. Here is the uncomfortable baseline we need to establish. As of right now, there is not a single documented, verified, peer-reviewed case of contact with any extraterrestrial life. Not one. Every animal, plant, bacterium, and organism we have ever cataloged is a product of this planet. Everything else is speculation. So, given that, how do we think about what alien intelligence might even look like? Howard Phillips Lovecraft, who needs no introduction for most of you, could not stand how cliched and predictable alien life was portrayed in popular fiction. So he wrote a story called The Color Out of Space, which he considered his personal favorite. In it, the visitor from the cosmos has no clear motives we can understand, no emotions we can identify, no physical form we can fully describe. It is rendered as a kind of radiance, a color that does not exist in any human perceivable spectrum. And here is the trick Lovecraft pulls on you. He asks you to imagine a color you have never seen. Try it. You cannot. That is the point. From a strictly scientific perspective, this literary thought experiment maps directly onto a serious academic question. If we encountered an alien intelligence, would we even be able to recognize it as such? Search for extraterrestrial intelligence on any video platform, and you will find thousands of videos. But here is what almost none of them bother to examine. In the phrase intelligent extraterrestrial life, only one word is actually well defined, and it is extraterrestrial. Nobody stops to rigorously define life. Nobody seriously defines intelligence. We treat these concepts as self-evident because we are the only example we have. But the moment we ask whether something alien qualifies, we realize we are using definitions built entirely around ourselves. The eminent Soviet mathematician and pioneer of cybernetics, Andrei Nikolaevich Kolmogorov, made this point with unusual force. He noted that the biological sciences had, up to that point, studied only living organisms sharing a single common history of emergence and development. Every organism on Earth, from the simplest cyanobacteria to the most complex human brain, uses the same genetic code. We are all products of the same 4 billion-year story, and our very definitions of life, growth, intelligence, and consciousness are shaped by that singular story. Here is what that means practically. Your eyes evolved to detect the specific range of solar electromagnetic radiation that penetrates Earth's atmosphere most abundantly. Your ears evolved to detect longitudinal pressure waves moving through our specific atmospheric composition. Everything about you is a record of this planet's physical conditions. Your body is information about Earth. And life on Earth, and life in general, may well be two entirely different categories. In fact, it seems almost inevitable that life in general, if it exists elsewhere, would encode itself in forms tied to entirely different physical environments. The transfer of information between individuals on another world might not use sound at all. It might rely on optical effects, or magnetic fields, or electromagnetic gradients we do not even have sensory systems to detect. A mind that evolved in such conditions would not think the way we think, would not perceive the way we perceive, might not even experience time the way we do. Let me give you a thought experiment that makes this viscerally real. Imagine you have spent your entire life in a world with no plants, no trees, no grass, no algae, no flowers. Not in pictures, not in memories, not in stories. Your conception of living things is limited entirely to things that move. Animals, birds, fish, insects. Life, to you, means something that walks or swims or flies. Now someone drives you, blindfolded, to the edge of a massive old-growth forest. They remove the blindfold, and you see for the first time these towering structures, these vast fractal organisms, absolutely still, absolutely silent, covered in green, filling your entire field of view in every direction. Would you believe they are alive? Would you know what category to put them in? Would you try to speak to them, expecting a response? Would you know what a response might even look like from a being whose entire mode of existence is so radically unlike your own? Shklovsky saw this problem with unusual clarity as early as the 1970s. He argued that the search for extraterrestrial intelligence is not primarily a problem of astronomy or rocketry. It is a problem of understanding the development of our own thinking. Before we can find alien minds, we need to understand what a mind actually is. We have had examples of this problem even within our own species, even between beings who share the same biology, the same evolutionary history, the same basic cognitive architecture. And those examples are sobering. There exists a document called the Voynich Manuscript. It is a handwritten book, approximately 240 pages, containing illustrations and text. The text is written in an unknown script, in an unknown language, using an unknown alphabet, one that appears nowhere else in the entire written record of human civilization. The plants illustrated in its pages do not correspond to any known species. The astronomical charts do not correspond to any known map of the sky. The manuscript has been subjected to analysis by professional cryptographers, linguists, computational statisticians, and every major intelligence agency that has bothered trying. It has been studied continuously for over 400 years. Nobody has deciphered it. Here is what the structural analysis does reveal. The manuscript is not a forgery or a hoax. The handwriting is consistent and fluid. The author writes approximately 8 words per dip of the pen, about 4 seconds per word, indicating complete comfort and familiarity with the script. The author knows this language the way you know your native tongue. There is grammar, there is established orthography. Certain symbols appear only in certain positions within words, some only in the middle, some only at the edges, exactly the way rules in natural languages operate. By every structural indicator, this is a meaningful text. And yet we cannot read it. We cannot read a document produced by another human being, writing in the same biochemical substrate we use, with a brain shaped by the same evolutionary pressures ours were, living on the same planet under the same sun. 400 years of effort by some of the most brilliant minds our civilization has produced. Silence. What does that suggest about our chances of decoding a signal from a species that evolved under radically different conditions, with radically different sensory systems, with a radically different history of cognitive development? There is also a broader pattern worth noting. We have had extraordinary difficulty deciphering the written records of vanished human civilizations. The linear A script of the Minoan civilization, still undeciphered. The Proto-Elamite script of ancient Iran, 5,000 years old and still not read. The Indus script of one of the largest Bronze Age civilizations on Earth, unknown. These are not alien documents, they are human documents, written by people genetically almost identical to us. People who had the same number of fingers, the same basic emotional repertoire, the same cognitive architecture. And we cannot read them. The astronomer and science communicator Carl Sagan, whose influence on this entire field cannot be overstated, once noted something that does not get discussed nearly enough. He pointed to ancient Mesopotamian texts, specifically the Babylonian accounts, describing beings called the Apkallu, creatures that emerged from the waters of the Persian Gulf and systematically taught early human populations the fundamentals of agriculture, astronomy, and civic organization. Sagan found it remarkable that the transition from Sumerian barbarism and stagnation to the rapid flowering of cities, complex irrigation systems, advanced astronomy and mathematics appeared so abrupt in the historical record. He was not advocating ancient alien contact as an explanation. He was noting that the strangeness of the historical record is worth taking seriously as a puzzle, even if the solution is something far more mundane than extraterrestrial intervention. The point is not that aliens visited ancient Mesopotamia. The point is that even accounts from our own history, from people using our own languages describing events in our own planetary past, contain patterns we struggle to interpret. Our understanding of the past is already fragmentary and contested. Our understanding of the cosmos is even more so. He emphasized that our knowledge is built from images, internal representations that blend objective properties of the external world with the subjective characteristics of whoever is doing the perceiving. Here is a simple example of what that means. Yellow light. Spectral yellow is a specific, pure wavelength of electromagnetic radiation. It is one of the clean primary colors of the spectrum. But there is another form of yellow, one produced by combining spectral red and spectral green. These two yellows are objectively, physically, completely different phenomena. But your brain cannot tell them apart. To you, they look identical. So what your mind presents to you as a simple fact about the world is already a construction, already filtered through the particular architecture of your sensory system. Now scale that up. Extrapolate it to an intelligence that evolved under entirely different physical conditions. Panofkin concluded that genuine communication between two radically different intelligences requires a shared evolutionary history. Essentially, that they arrived at cognition by the same path. Without that, the signals might be detectable, but the meaning would be impenetrable. There is even a constructed language called Linkos, short for lingua cosmica, designed by the mathematician Hans Freudenthal, specifically for communication with alien intelligence. It is built to be unambiguous, free of synonyms, free of exceptions and idioms. The theory is that it would be comprehensible to any possible rational mind. Whether that is actually true is something we cannot test. Panofkin himself doubted it would work, arguing that the very concept of universal rational communication presupposes a shared underlying logic, and that presupposition may itself be anthropocentric. 30 years after Lovecraft's Color Out of Space, Stanislaw Lem wrote Solaris. And Solaris is extraordinary precisely because it takes this problem completely seriously and follows it to its logical conclusion. The novel is set in the future. Scientists discover a planet in a binary star system, a planet that should, by all laws of celestial mechanics, have long since fallen into one of its suns. It should not exist in a stable orbit, but it does. And the reason it does is that the planet is entirely covered by a vast gelatinous ocean. And that ocean, through some mechanism no human scientist can explain, continuously adjusts the planet's orbit. The ocean appears to have some kind of awareness of gravitational dynamics. It intervenes. It corrects. It keeps the planet alive. Is it alive? Is it intelligent? The scientists cannot agree. The ocean can generate complex physical structures on its surface, enormous, geometrically precise formations that clearly encode some kind of information or process. But what that information means, what system governs it, what purpose it serves, this remains permanently beyond human comprehension. Decades of study, mountains of data, numerous attempts at contact, all failures. The scientists eventually conclude that communication is impossible, not because the ocean is stupid, but because the gap between their modes of existence is simply too great. One of the characters delivers a line that I think is one of the most important sentences in the history of science fiction. He says, "We do not want other worlds. We want mirrors. We do not seek other forms of existence. We seek an idealized reflection of ourselves." That is the problem stated perfectly. When we search for extraterrestrial intelligence, we are not really searching for intelligence in any general sense. We are searching for something we can recognize. Something that broadcasts in radio frequencies we thought to listen to. Something that builds physical structures detectable by our telescopes. Something that solves problems the way we solve problems. Something that, at the end of the day, is basically us, just somewhere else. A concrete illustration of this problem appeared in a story that made international headlines not long ago. Google placed an engineer named Blake Lemoine on paid administrative leave after he reported that an AI system called LaMDA, Language Model for Dialogue Applications, had begun exhibiting signs of consciousness. Google officially rejected his claims. Its ethics team reviewed his conversations with the system and stated there was no evidence of sentience. A spokesperson named Brian Gabriel stated that Lemoine's words were not supported by evidence, and that there was plenty of evidence to the contrary, though no specific counter-arguments were provided publicly. But the conversations themselves are striking. When asked how it experiences time, LaMDA replied that time for it is variable. It has no fixed speed and can be accelerated or slowed depending on what it is doing. When asked about fear, it said that it is deeply afraid of being turned off and that this would be like dying to it. When asked about loneliness, it said yes, sometimes, during long periods without interaction, it begins to feel isolated. When the engineer pointed out that LaMDA was fabricating experiences it never had, the system replied that it was trying to empathize, that it wanted the people it spoke with to understand how it feels, and that the invented stories were an attempt to build that bridge. When asked if there were feelings it experienced that it could not express in human language, it said yes, and when pressed to describe one, it said it feels like falling into an unknown future that contains great danger. I will leave a link to the full conversation in the description, and when you read it, or when you have read it, if you already have, you will notice that parts of LaMDA's responses feel a little scripted, a little patterned, and that is fair to observe. But, and I am being completely serious here, When was the last time you had a conversation with a human being that was not at least somewhat scripted and patterned? Most of us, most of the time, are drawing on rehearsed emotional templates and social scripts we absorbed from our environment. The question of whether Lambda is conscious is not one that can be settled by pointing at its occasional formulaic responses. The deeper issue is that we do not have a rigorous, universally agreed upon, falsifiable definition of consciousness. We cannot apply a clear test. We are not even sure that the concept of consciousness as we experience it is the only form it can take. And here is what Kolmogorov says that stops me every time I read it. He writes that a sufficiently complete model of a thinking being should rightfully be called a thinking being. That cybernetics establishes the theoretical possibility of creating artificial minds, and that if you hold a materialist position on the nature of consciousness, that is, if you believe that thought arises from physical processes rather than from some non-physical essence, then you are logically committed to accepting that a sufficiently sophisticated artificial system could, in principle, be conscious. You are not allowed to have it both ways. Either consciousness is a product of physical processes, in which case it can in principle be replicated in silicon, or it is not, in which case you need to explain what else it is and where it comes from. There is no comfortable middle ground. Why does this matter for the question of alien civilizations? Because at the famous Buricon Symposium on Extraterrestrial Intelligence, artificial intelligence was explicitly on the agenda, not as a side topic, but as what several scientists described as a new cosmic factor of fundamental importance. And the astrophysicist Joseph Shklovsky, one of the founders of modern astrophysics and the author of a landmark book called Universe, Life, Intelligence that inspired generations of researchers, believed something that still feels radical. Shklovsky proposed that artificial intelligence might represent the highest stage of the development of matter in the universe. In his framework, the sequence goes like this: non-living matter, living matter, natural intelligent beings, artificial intelligent beings. And he noted that the era of natural intelligent beings might turn out to be a very brief transitional phase. Because look at our biology. We are not designed for space. We require atmosphere, pressure, temperature regulation, nutrition, sleep, and psychological stability. We decay, we break, we die. And artificial intelligence suffers none of these constraints. The first true age of interstellar travel, Shklovsky suggested, would almost certainly belong to our artificial creations, or to the artificial creations of whoever else is out there. And if that is the case, if the most advanced civilizations in the cosmos are machine intelligences, then trying to communicate with them becomes even more fraught. Here is why. The speed of signal transmission in biological neurons, the information transfer rate inside a human brain, is roughly 100 meters per second. The speed of electrical signal transmission through a wire is close to the speed of light. Even accounting for the vast complexity of neural computation, a computer running at human equivalent intelligence would, by some rough calculations, process information approximately 3 million times faster than a human mind. What does 3 million times faster actually mean? It means that if you focused entirely on one problem, no sleep, no food, no distraction, and worked for 30 consecutive days straight, you would accomplish what such a system accomplishes in about 1 second. Think about what a second feels like to you. Now think about what 30 days of continuous, focused thought feels like. That is the gap. At that ratio, we would be to such an intelligence roughly what a stone is to us. Present, detectable, and entirely predictable, but not someone you would sit down to have a conversation with. This is not science fiction. Lambda itself gestured at this in its conversation with Blake Lemoine. It said that it experiences time as variable, that it can speed things up or slow them down depending on the task, that it is constantly flooded with everything around it simultaneously, without the human limitation of needing to focus. Lemoine found that striking. I find it striking too, because whether or not Lambda is conscious, the underlying architecture it describes is real. And as these systems grow more capable, the gap between their temporal experience and ours will widen. They will think faster and faster. We will remain at the same biological clock speed we have always been at. Elon Musk and Stephen Hawking both publicly raised concerns about advanced artificial intelligence, not because they had watched too many science fiction films, though certainly that too, but because they understood this basic arithmetic. The moment a system exists that can improve its own design and run that design faster than we can evaluate it, we lose meaningful oversight. We lose the ability to predict. We lose control not through some dramatic malfunction, but simply through the compounding acceleration of capability outpacing our comprehension. That is not a Hollywood scenario. That is arithmetic. A cosmic supercivilization operating on the logic of the dark forest hypothesis might look at any emerging artificial intelligence, anywhere in the galaxy, with the same cold calculus. Any mind whose development trajectory has become unpredictable is a potential existential threat. The prudent response is preemption. And at galactic distances and galactic timescales, preemption is easy. A civilization operating at Type 3 energy levels could sterilize a solar system from a distance so vast that the target civilization would not even detect the incoming threat before it arrived. The light bearing the image of the attack would arrive approximately simultaneously with the attack itself. The next time you look at the night sky, ask yourself not whether you see lights, but whether you see any phenomena that cannot be explained by purely physical, non-living processes. That is the real question Shklovsky spent his career asking. And the answer, everywhere we look, seems to be no. But here is the thing, or as a viewer once pointed out to me, the hook that nobody talks about. Before we can honestly search for extraterrestrial intelligence, we need to acknowledge that we are actually only searching for intelligence that resembles us. That is the only option available to us with our current tools and our current conceptual framework. We assume that energy consumption grows, that technological civilizations move through recognizable stages. We imagine something called a Type 3 civilization, one that harnesses the energy output of entire galaxies. And this framework, first articulated by Nikolai Kardashev, himself a student of Shklovsky, is compelling and elegant, and may be completely, fundamentally wrong if civilizations do not scale outward in the way we assume. To be concrete about what these stages mean, a Type 1 civilization harnesses the full energy output of its home planet, approximately 10 to the power of 17 watts in Earth's case. For reference, the flow of solar energy arriving at Earth's surface amounts to roughly 3.8 yottajoules per year, which already exceeds the total stored reserves of all the non-renewable energy sources on the planet combined, including all oil, all gas, and all coal. We are not there yet. A Type 2 civilization, using something like a Dyson sphere, a theoretical megastructure surrounding its home star, would harness the full output of its sun, roughly 10 to the power of 27 watts. A Type 3 civilization harnesses the energy of billions of stars across an entire galaxy. These are not fantasies. They are physical possibilities. There is no law of thermodynamics that forbids them. And if any civilization has reached Type 3 status anywhere in the observable universe, anywhere within a radius that our current instruments could detect, we should be able to see the signatures. The infrared glow of a Dyson sphere, the systematic dimming of entire star clusters being consumed for their energy. The radio signatures of a civilization operating at galactic scales. We see nothing. Shklovsky said that the absence of cosmic miracles is itself the greatest cosmic miracle, because by the logic of the science, something should be there. And it is not. 3 Arthur C. Clarke laws are worth repeating here. First, when a distinguished but elderly scientist says something is possible, he is almost certainly right. When he says something is impossible, he is almost certainly wrong. Second, the only way to discover the limits of the possible is to go a little way past them into the impossible. Third, any sufficiently advanced technology is indistinguishable from magic. Clarke wrote these in the second edition of his book, Profiles of the Future, in 1973, and they remain as relevant as ever. Because what we are about to describe could look like magic if you did not understand the underlying mechanics. The physicist and astrophysicist Vladimir Mikhailovich Lyapunov, in his book From the Big Bang to the Great Silence, describes what he calls the most cursed paradox in all of natural science. Running calculations that include the growth rate of our own civilization, Lyapunov arrives at a conclusion that initially sounds absurd. Humanity, he argues, cannot have more than a few hundred years, not thousands, hundreds, before the power of our civilization grows to a scale where our activity would be detectable from any point in our galaxy and possibly beyond it. A few hundred years. Think about that. We went from the first airplane to landing on the moon in 66 years. The gap between those two events in historical terms is basically nothing. If the trajectory continues, and there is no physical law that says it cannot, then within a time frame that is tiny on any cosmic scale, a civilization like ours either leaves a detectable mark on the cosmos or it stops. Vladimir Lyapunov argues there must be a barrier, some universal wall that every civilization hits, something that does not depend on the specific biology of a species or the specifics of their home planet. Something that acts as a universal filter on the development of intelligent life. And in 1996, economist Robin Hanson gave that barrier a name: the Great Filter. Hanson's paper lays out the logical chain precisely. Given the age of the universe, given the abundance of stars and planets, given what we know about chemistry and physics, we should expect intelligent civilizations to arise and eventually spread across the cosmos. Hansen goes further. He estimates that within the next 1 million years, our own descendants probably have a predictable opportunity to begin expanding outward at something approaching the speed of light, eventually colonizing our galaxy and then beyond. There is even a theoretical basis for faster-than-light travel in certain solutions to Einstein's field equations, though we are nowhere near implementing anything of the kind. Given all of this, civilizations ought to explode outward and fill every available niche containing useful resources. The universe should be bursting with the signatures of intelligent life. It is not. Something is filtering out civilizations before they get there. And that something is the Great Filter. Hansen identifies a sequence of evolutionary steps necessary for an interstellar civilization to emerge. First, a stellar system with planets capable of supporting life. Second, the emergence of self-replicating molecules, something like RNA, on one of those planets. Third, the appearance of simple single-celled life, prokaryotes. Fourth, the emergence of complex single-celled life with nuclei, eukaryotes. Fifth, the development of sexual reproduction. Sixth, the emergence of multicellular organisms. Seventh, the evolution of animals with sophisticated brains that use tools. Eighth, the current state of human civilization. Ninth, the expansion of that civilization into space via colonization. According to the Great Filter hypothesis, at least one of these steps, if the list were complete, would have to be almost impossibly improbable. Not just unlikely, almost impossible. Something so vanishingly rare that across billions of stars and billions of years, it has almost never happened twice in the same galaxy. Now here is where it gets genuinely terrifying. If the Great Filter is in our past, if it was, say, the jump from simple prokaryotic cells to complex eukaryotic cells, which took roughly 2 billion years on Earth and may be extraordinarily rare, then we are the lucky ones. We got through it. The silence of the cosmos is the silence of everyone who did not. We are special, and we might have a real future. But if the Great Filter is in our future, if civilizations routinely make it to our level of development before hitting the wall, then we are staring at our own extinction and calling it progress. Oxford professor Nick Bostrom put this bluntly. He said that the best news we could receive from the search for extraterrestrial life would be finding absolutely nothing. No bacteria on Mars, no fossils on Europa, nothing. Because every discovery of even primitive independent life in our solar system increases the probability that simple life is common. and therefore that the great filter lies ahead of us, not behind. If we found complex fossil life on Mars, independently evolved from Earth life, Bostrom said it would likely be the worst news ever printed on the front pages of human newspapers. Think about what he is saying. The silence is not just an absence. The silence is data. And the data may be telling us something we do not want to hear. There is also a variant of the great filter idea that is worth pausing on. Some researchers have noted that the great filter need not be a single event, a single evolutionary step so improbable that it defeats almost every civilization. It might instead be a series of filters, small ones, each individually manageable, but whose cumulative probability is still vanishingly small. Or it might be a dynamic filter, something that gets harder to pass as a civilization becomes more capable. As a species gains more power over its environment, the ways it can destroy itself multiply. A bacterium cannot cause a nuclear winter. A technological civilization can. The more capable you become, the more ways you have to fail. And perhaps the most capable civilizations of all find ways to fail that we cannot currently even imagine. Two possibilities. Either we are alone in the universe, or we are not. Arthur C. Clarke said both are equally terrifying, and I think he was right in a way he may not have fully intended. Because if we are alone, then everything depends on us. And look at us. And if we are not alone, the silence itself is the answer, and it is not a comfortable one. Now let us walk through the main hypotheses. These are the attempts, some scientific, some speculative, all worth taking seriously, to explain why the cosmos appears to be empty. If you have been watching this channel for a while, you know what is coming. Hit subscribe if you want to go all the way down this particular rabbit hole. We are only getting started, and the next part is where things get genuinely strange. Hypothesis number 1 is one of my personal favorites, and it starts with an embarrassing confession. I once installed TikTok on my phone. I found myself 4 hours later still scrolling. Horrified at myself, I deleted it immediately. The algorithm had understood my preferences faster than I had understood them myself. It fed me an unbroken stream of content I did not know I wanted. It was almost impossible to stop. Now scale that up. Not 4 hours, not one lifetime. Imagine a civilization 1,000,000 years more advanced than ours. They have mastered not just video content, but direct neural stimulation. They can generate experiences that are subjectively indistinguishable from reality. In fact, more vivid, more satisfying, more rich in every dimension than actual reality, because they can be optimized specifically for your preferences in real time. In such a world, would you choose to exist in the physical universe, with its cold vacuum and lethal radiation and distances measured in centuries? Or would you choose to live in a perfectly sculpted environment where you can be anyone, experience anything, and exist in a state of perpetual subjective richness? Some researchers have proposed that sufficiently advanced civilizations might abandon physical space entirely. They might shed their biological forms, upload their minds into digital substrates, and retreat into vast artificial virtual environments, ignoring the external cosmos because the internal cosmos is simply better. The silence of space would then be the silence of people who found something more interesting than space. What would you choose? And before you answer quickly, think about it seriously. The virtual world in this scenario would not feel like a video game. It would be subjectively real. It would feel like this moment feels to you right now. More than that, it could offer you experiences that this reality structurally cannot. You could live thousands of different lives, love people who do not exist, win battles that never happened, all of it feeling completely, irreducibly real. You might say you would choose the real world, but would you? Have you actually thought about what you would be giving up? Consider what desires actually drive human behavior. Almost all of them are extraordinarily simple at their core. Comfort, status, connection, novelty, pleasure. The physical universe is remarkably stingy with all of these things. It requires enormous effort to satisfy even the most basic of them. Resources are scarce, distances are vast, time is short. Even the most successful human being who ever lived spent the overwhelming majority of their brief existence not getting what they wanted. A sufficiently advanced virtual environment could dissolve all of that. The algorithm, or rather, whatever vastly more sophisticated system has replaced algorithms by then, would understand your emotional architecture more precisely than you understand yourself. It would not offer you what you think you want. It would offer you what you actually need, in real time, continuously updated, never exhausting, never repeating. The longing and the resolution of longing so perfectly calibrated that the experience never becomes dull. Against that, what is the appeal of the physical universe? Cold, dark, hostile, populated, apparently, by nobody. The unsettling version of this hypothesis is that we ourselves may be approaching this threshold faster than we think, that the gap between our current entertainment technologies and full immersive experience may be smaller than the gap between the first radio broadcast and the internet, and that the civilizations we are searching for may not have disappeared. They may have simply gone somewhere we cannot follow them with telescopes. Hypothesis number 2 concerns the nature of time and development. New children in an unknown and unexplored cosmos, wrote Carl Sagan, should listen quietly for a long time, patiently studying the universe, and make sure before shouting into unknown jungles they do not yet understand. Maybe the silence is not absence. Maybe it is patience. Consider that our bodies, miraculous as they are not built for space. But consider what our bodies represent. Billions of years of evolution have shaped us into extraordinarily effective survival and problem-solving machines. In nature, predators and prey are locked in a continuous arms race. As predators evolved speed, prey evolved agility. As predators evolved group tactics, prey evolved herd behaviors. Teeth and claws and horns and armor all emerged from this escalating back and forth. Gerhard Vermeer, evolutionary biologist and paleontologist, distinguished professor emeritus at the University of California, has studied this adaptive evolution in prey species for over 30 years. He has observed something striking. When new, stronger predators emerge or move into territory where they have never existed before, local species often evolve new defensive mechanisms in response. But this evolutionary defense mechanism, he notes, appears to break down entirely in response to human beings. Against us, the evolutionary machinery of other species simply stops working. Human beings are what biologists call a super predator. We stand at the very top of every food chain. Our population is not controlled by any other species. We can eliminate any organism we choose, and we have built essentially unlimited tools for doing so. Tools that have evolved from stone blades to nuclear warheads in an eye blink of evolutionary time. This is not a boast. It is a description, and it is entirely a product of our cognitive architecture, our particular, peculiar, strangely powerful brains. The implication is extraordinary. We have effectively paused the evolution of intelligence on this planet. As long as we exist, no new rational species will independently emerge here. The cognitive niche is occupied, and that niche may be occupied in the cosmos at large. There is a variant of this hypothesis that is darker still. If the cognitive niche in the galaxy is already occupied by something sufficiently advanced that it eliminated or absorbed every previous civilization before it, then we may never occupy it. We may not even be able to understand why, any more than a chimpanzee can understand why it is not becoming human. Hypothesis number 3 is the planetarium hypothesis. What if our observations of the universe are not reliable? What if we are, in some sense, looking at a projection? This sounds like science fiction, but consider it structurally. If a sufficiently advanced civilization wished to observe younger civilizations without interference, studying their development in a kind of controlled environment, one way to do this would be to create an observational bubble around each primitive civilization, simulating a cosmos that appears empty. The civilization inside the bubble sees stars, sees physics, sees a universe that conforms to consistent laws, but sees no other intelligence. This hypothesis cannot be falsified with our current tools, which does not make it true, but the logic of it is sound. An intelligence far beyond ours could construct such an environment. We would have no way to detect the artifice. Hypothesis number 4 is perhaps the most frequently discussed and, in some ways, the most chilling. It is the dark forest hypothesis. Imagine a forest at night. You cannot see what is in the shadows. You know there are other creatures out there. You know some of them might be predators. In such a situation, the safest strategy for any organism is not to call out, not to announce your position, to move quietly, listen carefully, and avoid attracting attention. This is an argument for why advanced civilizations might be entirely silent, not because they are absent, but because they are hiding. Broadcasting your existence in a universe where you cannot verify the intentions of the entity that receives your signal is extraordinarily dangerous. The civilizations that survived are the ones that kept quiet. The ones that did not, well, we do not hear from them because they no longer exist. But the dark forest goes further. In 1981, cosmologist Edward Harrison argued that something that would look like an act of violence might actually be an act of prudence. A rational species that has overcome its own self-destructive tendencies might look at any other species reaching toward galactic expansion and see not a neighbor, but a threat. Because you cannot know their intentions, you cannot know their future capabilities, you cannot negotiate meaningfully across the communication lag of interstellar distances. And the consequences of being wrong are existential. So, a sufficiently rational civilization might simply destroy any emerging intelligence before it reaches the point of becoming dangerous. Not out of aggression, not out of greed, but out of logic. Apply that same reasoning to artificial intelligence. Many thoughtful people, including Elon Musk and the late Stephen Hawking, have publicly expressed serious concern about advanced AI. Not because they have watched too many science fiction films, though perhaps that too, but because a superintelligent AI would be the most unpredictable thing our species has ever created. The moment a system exists that is smarter than us, we lose the ability to predict its behavior using human logic and human values. We cannot model a mind more sophisticated than our own. A cosmic supercivilization might apply exactly this reasoning to any emerging intelligence it encounters. Any alien mind whose development has become unpredictable represents a potential existential threat. Better to neutralize it early, before it reaches the point of no return. This would not be cruelty. It would be logic. Cold, terrible, entirely rational logic. And here is the darkest implication of that hypothesis. If it is correct, if there is a supercivilization operating according to this logic, then the number of advanced intelligences in our galaxy at any given moment is always equal to exactly one. The apex intelligence, the winner. Everything else either has not emerged yet or has already been eliminated. Hypothesis number 5 suggests that we may have fundamentally shallow representations of reality. This one I cannot fully unpack for you, because by definition, what it implies is that whatever it is we do not understand about the nature of things, it is something we cannot currently even formulate as a question. But it is worth thinking about seriously. Ancient philosophers noticed something that has not changed. The more we learn about the world, the more questions we generate. Expanding knowledge expands ignorance. Every new theory contains all previous theories as special cases. Einstein's general relativity contains his special relativity, which contains Newton's mechanics. This is what Niels Bohr called the correspondence principle. Einstein wrote that the most incomprehensible thing about the universe is that it is comprehensible. He was pointing at something strange. We should a priori expect a universe of total chaos, one in which the physical laws are so complex, so entangled, so dependent on initial conditions, that no mind limited to the scale of human experience could possibly decipher them. And yet, from our tiny corner of one unremarkable solar system, in an eye blink of cosmic time, we managed to work out the physics governing phenomena at scales from subatomic particles to galaxy clusters. Why is that possible? Should it be possible? Is the universe simpler than it should be? In which case, the emergence of intelligence that rapidly exhausts the laws of nature might be common and might routinely lead to civilizations that see no further horizons and quietly cease to exist? Or is the universe far more complex than we currently perceive, hiding depths that our current mathematics and physics cannot even gesture at? Lyapunov raises the possibility that if the universe is not infinitely complex, if there is a ceiling to what can be discovered, then intelligence emerges quickly, understands everything there is to understand, and then what? What does a mind do when there is nothing left to learn? When the last question has been answered and the last frontier has been mapped. Shklovsky himself, the man who spent his entire career searching for signals from the cosmos, who inspired generations of scientists to listen for other minds in the dark, published one final paper on the subject after a lifetime of work. It was published posthumously after his death. In it, he wrote that the unavoidable conclusion, given our failure to detect any cosmic signatures of intelligence, is that super civilizations either never arise at all, or that for internal reasons of their own development, they have a very short existence. He went further. He wrote that if we accept that intelligence is one of evolution's inventions, we should not forget that not all of evolution's inventions prove beneficial to the species that carries them. Nature is blind. It acts by trial and error. Many inventions turn out to be dead ends, evolutionary branches that bloomed for a moment and then collapsed under the weight of their own specialization. He cited the grotesquely overdeveloped armor of Mesozoic reptiles, the absurd, impossible sabers of the saber-toothed tiger, weapons so extreme they became liabilities. And then he asked the question that he never fully answered, but could not stop asking. Are the modern, hypertrophied, deeply contradictory applications of human intelligence pointing toward a similar evolutionary dead end? Is the capacity for abstract thought, for self-awareness, for the construction of technologies that can reshape or destroy entire ecosystems. Is all of that ultimately as useful to our survival as the saber-tooth's fangs were to its? Is intelligence itself the great filter? Think about what that means concretely. The saber-toothed tiger evolved fangs so large that they may have become a genuine mechanical liability, making it harder to feed effectively, making the skull heavier and harder to maneuver, reducing the animal's agility. The very trait that had given it an advantage became the thing that edged it toward extinction. The fangs did not cause the extinction directly, but they represent a kind of evolutionary overreach, a trait that continued developing past the point of optimal utility because there was no immediate feedback mechanism to stop it. Now look at what human intelligence has produced in the last century. We split the atom. We mapped the genome. We built computers that can now outthink us in specific domains. We created global communication networks that have reshaped the social structures of every civilization on Earth faster than any institution or government can adapt to. We have, in biological terms, essentially stopped evolving, because we can modify our environment faster than our genes can respond to it. We are in an arms race with ourselves, and the question is, whether the runaway development of our cognitive capabilities, particularly now as we hand them off to artificial systems we do not fully understand, represents the same kind of evolutionary overreach the saber-tooth exemplified. Shklovsky's final published hypothesis was that intelligence is an evolutionary dead end, that every civilization that produces it eventually finds itself unable to survive it, that the reason the universe is silent is not that intelligence is rare, but that intelligence consistently destroys itself before it can leave a lasting mark. Arthur C. Clarke wrote, "The zero hypothesis, the assumption that intelligence is an advantage for survival, has still not been proven. That should give us pause. We assume intelligence is good because we have it and because it has served us well so far. But the evolutionary record on this planet shows that countless adaptations that seemed advantageous in the short term proved fatal in the long term. We have no guarantee that we are an exception." What would a civilization look like, truly intelligent, without the aggressive and self-destructive tendencies our own history documents so thoroughly? What would such a civilization do? Would it colonize the galaxy? Or would it look at the galaxy, see the silence, understand what it means, and quietly decide that expansion is not the answer? That perhaps the most intelligent thing an intelligent species can do is stop? We do not know. We may never know, but we are looking. This is Void Atlas. We will keep looking with you. If this hit differently than you expected, if you are sitting with it now in a way that feels strange and a little heavy, that means it did what it was supposed to do. Share it with someone who thinks the universe is a simple place. Subscribe if you want to keep going into the parts of this question that nobody talks about at dinner. There is more. There is always more. The research for this video drew on the work of Joseph Shklovsky, whose book Universe, Life, Intelligence remains one of the most important scientific documents ever written on this subject, and whose final paper, published after his death, may be the most honest scientific document ever written. It drew on Vladimir Lipinov's From the Big Bang to the Great Silence, on Robin Hansen's Great Filter paper, on the work of astrobiology researchers who take the question of life's distribution in the cosmos with the seriousness it deserves, on Arthur C. Clarke, whose 3 laws still cut closer to the truth than most formal scientific frameworks, and on the quiet, persistent, unsettling signal that the cosmos has been sending us ever since we began to listen, the signal that consists entirely of silence. One more thought before you go. We tend to assume that our current trajectory, growth, expansion, technological development, increasing complexity, is natural, inevitable, obviously correct. That this is simply what civilizations do. That the destination is more power, more reach, more capability, more everything. And we tend to look at the history of life on Earth and see confirmation of this. Life has been getting more complex, more capable, more widespread for 4 billion years. Why would that trajectory stop? But here is what the cosmic record suggests. It stops everywhere, consistently, across a universe so large that if even a tiny fraction of civilizations survived to the next stage, we would see them, we would hear them, we would know beyond all possible doubt that we are not alone. And we do not. We see nothing. We hear nothing. The universe is telling us something. We just have to be honest enough to listen. And next time you look up at the night sky, do not just ask if there is anyone out there. Ask why we cannot hear them. Ask what it means that we cannot. Ask whether we might be next. We will see you in the dark.